Welcome to the Explainer. Today we're digging into something pretty wild, a blockchain update from the Qubitcoin Network called Superdense Consensus. And trust me, this isn't just a small tweak. It could completely change what we think a blockchain is even for. But before we get into the nitty-gritty, let's start with a really big question. Think about it. What if all that incredible computing power that secures a blockchain could do more than just solve, random puzzles? What if we could point it at real-world scientific problems? Just keep that thought in the back of your mind as we go through this. So here's how we're going to break it all down. First, we'll take a quick look at how things used to work. Then, we'll get into this new idea of a multi-puzzle blockchain. After that, we'll see how this super dense engine actually keeps the whole thing from falling apart. And then, the really cool part, how we go from just solving puzzles to tackling real problems, which opens up a whole new market. We'll even touch on what this means for a quantum platform. Let's get into it. All right, section 1, the old way. Look, to really get why superdense is such a big deal, we've got to first understand what it's replacing, the way blockchains have always operated. Okay, so picture this. A traditional blockchain, like Bitcoin or even the original Qubitcoin, is kind of like a giant video game where literally everyone is trying to solve the exact same puzzle over and over again. All that computing power, all those miners, all pointed at one single target. It's a one-size-fits-all race to the finish line. And that old system was, well, really rigid. You had just one type of proof of work, right? One difficulty level for everybody that would adjust across the whole network. And because of that, there was really only one path forward. Now, don't get me wrong, that made it super secure and stable, but it was also kind of boring. It was incredibly limited in what it could actually do. All right, so now we get to super dense, and it basically takes that old single puzzle rulebook and just chucks it out the window. This is a completely new way of thinking about what a blockchain can actually work on. So the key idea here is this new thing called a task. And don't just think of it as another puzzle. It's more like a self-contained job for the computer. Each task has its own special algorithm, its own set of rules, and, this is super important, its very own difficulty level that can change all by itself. The best way to think about it is that the blockchain goes from being a single-purpose video game to being more like the operating system on your phone. All these different tasks can run at the same time, just like different apps. So miners aren't stuck playing just one game anymore. They can actually choose which app or which task they want to run on their hardware. Okay, so right about now, you're probably thinking, wait a minute, if you've got all these miners jumping between different puzzles, doesn't the whole thing just turn into chaos? It's a great question. How does the network possibly stay stable? Well, here's the secret sauce. Each of these tasks manages its own difficulty all on its own. It's almost like they're little mini blockchains running inside the big one. So if a ton of miners jump onto task A, its difficulty goes way up. If everyone leaves task B, its difficulty drops. This is how the entire system stays balanced and fair, no matter where the miners are. And this is the really clever bit. Even with all this stuff happening, the overall network stays rock solid and predictable. So let's say you have 5 different tasks running. Maybe each one is set up to find a block every 50 minutes on its own. But since they're all happening at the same time, in parallel, the network as a whole still finds a block every 10 minutes. That core stability, that predictable rhythm, it's still there. Okay, so this is where it all comes together. This is the big payoff. Why does any of this matter? Who cares if you have multiple puzzles? Well, because it means the blockchain can finally stop solving just random, abstract puzzles and start solving real, useful problems. And this is not just some theory, okay? This is happening. The very first new task they've introduced is called David, and its whole purpose is to do what they call useful quantum work. Yeah, this is the moment the blockchain literally starts doing science. So here it is, the big aha moment. The old task, the Qash task, it did its job, it secured the network, but the output was basically just structured noise. The new David task, it also secures the network, but the thing it spits out at the end isn't noise. It's actual usable quantum circuits, a total game changer. So what does that actually mean in plain English? It means that for the first time ever, the work that miners are doing has real scientific value outside of the blockchain itself. The end result isn't just some random string of numbers anymore. It's clean, organized data that researchers can take and plug right into their tools for quantum science. That's huge.
So, when you make this shift from abstract puzzles to useful work, it changes the game for everybody. The whole dynamic flips, creating new reasons for people to participate and opening up brand new possibilities.
Think about it from a miner's point of view. Suddenly, it's a real free market. You're not stuck doing one thing anymore. You can look at all the available tasks and ask, okay, which one is going to make me the most money with my specific hardware right this second? You can switch on the fly, always looking for the best combo of reward, difficulty, and efficiency. It's all about maximizing your profit. And for the blockchain itself, the benefits are just massive. It becomes modular, like building with Legos. You can pop in new cutting-edge scientific tasks whenever you want. You can take out old ones that aren't useful anymore. And you can do all of this without a massive disruptive update, a hard fork. It means the chain can finally evolve and keep up with technology for decades to come. It's future-proof. All right, so let's take a step back and look at the big picture here. We've seen all the pieces. What's the grand vision? What does Superdense Consensus really make possible? I mean, look at this transformation. Before, Qubitcoin was basically a single algorithm coin. Now, it's a multi-algorithm network. Its output used to just secure the chain. Now, it secures the chain and it produces real science. So its whole identity changes. It stops being just a currency and becomes something way bigger, a distributed quantum compute platform. And really, if you want to boil it all down to one sentence, this is it. The genius here is that Superdense lets Qubitcoin run all these different proof-of-work algorithms at the same time, all while keeping the blockchain totally stable and spitting out real scientific data. It's the best of all worlds. And that brings us right back to where we started, and it leaves us with a pretty mind-blowing question. We've just seen that, yes, blockchain work can be used to solve quantum compilation problems. So what's next? Could we use this to design new drugs, to model climate change? The potential here for useful work is absolutely massive, and we're really just scratching the surface.